Welcome back to Cosmic Compass. Today, let's journey to one of the most extraordinary worlds in our solar system, Saturn. At first glance, it may seem familiar, the golden gas giant crowned with its iconic rings, but beneath its beauty lies a planet that defies the very rules of physics as we know them. From storms that should not exist to a magnetic field that challenges our understanding, Saturn is a cosmic enigma. So let's explore together, because the more we learn about Saturn, the stranger and more fascinating it becomes. When you think of Saturn, one image immediately comes to mind: its magnificent rings. They are the largest and brightest in the solar system, so iconic that Saturn almost feels familiar, like an old friend in the night sky. Yet behind that beauty lies a world that refuses to be simple. Saturn is the second largest planet, less dense than water, and the sixth planet from the Sun. But the truth is, Saturn breaks rules we thought we understood. It hides mysteries beneath its golden haze, mysteries uncovered not by stargazing from Earth, but through a spacecraft that dared to orbit it for over a decade. Saturn behaves in ways our models say it shouldn't. Its magnetic field defies theory. Its day seems to change length. Its atmosphere radiates more heat than it should. So let's ask ourselves, what is going on with Saturn, and how have scientists tried to solve these riddles? To answer, we'll follow the story of Cassini, the probe that turned Saturn from a distant jewel into a living puzzle. Cassini arrived at Saturn on July 1st, 2004. It was not the first visitor. 3 other spacecraft had performed flybys before, but Cassini was different. Instead of passing quickly, it stayed. For 13 years, it orbited the gas giant, patiently circling, studying, and sending home a treasure trove of data until its mission ended in 2017. In that time, Cassini captured nearly 500,000 images. It mapped Saturn's rings in detail, probed its magnetosphere, and even revealed close views of moons like Titan and Enceladus. But perhaps most importantly, it uncovered mysteries we had never expected. Through its instruments, spectrometers, magnetometers, cameras, Cassini observed Saturn's shifting clouds, its turbulent atmosphere, and the strange, almost geometric storms raging at its poles. It confirmed just how fast Saturn's winds are reaching, up to sudden 800 kilometers per hour, and it gave us the clearest view yet of the giant Hexagon swirling at the North Pole, a storm large enough to fit Earth inside. Yet for all the answers it provided, Cassini left us with deeper questions. Why does Saturn's atmosphere behave in ways that make no sense? Why does its magnetic field defy the rules of physics? And what secrets still lie beneath the clouds? Cassini had given us a window, but what we saw through it was astonishing. Among the most striking discoveries Cassini made was Saturn's great northern storm, shaped not as a circle but as a perfect hexagon. Imagine a jet stream so vast that each of its 6 sides could fit the entire Earth. This storm measures nearly 29,000 kilometers across, and yet it remains astonishingly stable, locked in place at Saturn's North Pole. On Earth, storms shift, dissipate and fade, but Saturn's hexagon has persisted for decades, perhaps centuries. It rotates with the planet, even as the rest of Saturn's atmosphere churns chaotically around it at incredible speeds of up to 1,800 kilometers per hour. How can such a precise geometric form exist in the turbulent chaos of a gas giant? In laboratories, scientists have been able to reproduce hexagonal shapes in rotating fluids under controlled conditions, suggesting that Saturn's jet streams could naturally settle into this pattern. But nothing we've created comes close to the sheer scale and longevity of Saturn's storm patterns. This is Saturn's way of reminding us that even in a universe governed by physics, some outcomes look almost too strange to believe. And if a storm can take the shape of a hexagon here, what else might be happening in the depths below those golden clouds? For a planet so large and prominent in our skies, you might assume we'd know something as basic as how long a day lasts on Saturn. But for decades, this simple question had no clear answer. On rocky worlds like Earth or Mars, the process is straightforward. Watch a surface landmark rotate back into view and you have the length of a day. But Saturn has no solid surface visible to us. Instead, it is cloaked in thick layers of cloud, whipped around by winds, moving at different speeds depending on latitude and altitude. What we see on the outside tells us little about what the core beneath is doing. The rings can't solve this puzzle either. They orbit Saturn at their own speeds, independent of the planet's interior rotation. So how do you measure a day on a world where the surface never sits still? Scientists turn to magnetism. On planets like Earth or Jupiter, the magnetic field is generated by the spinning of conductive fluids deep inside a process called the dynamo effect. Crucially, the magnetic pole is usually tilted relative to the planet's axis of rotation. By watching how the magnetic field wobbles as the planet spins, you can track one full rotation. But Saturn refused to cooperate. Cassini's instruments showed that Saturn's magnetic field is almost perfectly aligned with its axis within 1/10 of a degree. According to dynamo theory, such an arrangement shouldn't be stable, and yet Saturn's magnetic field remains strong and persistent, over 500 times more powerful than Earth's. Without a tilt, there was no magnetic wobble to measure. It was like trying to tell time with a clock that has no moving hands. Then came radio waves. Saturn emits bursts of radio emissions from its interaction with charged particles rising and falling in intensity. Early probes like Voyager used these pulses to estimate a day of about 10 hours and 39 minutes. Cassini confirmed this at first, but over its 13 years of observations, the rhythm shifted. Sometimes a day appeared longer, sometimes shorter, drifting by as much as 1% per year. Could Saturn really be changing the speed of its own rotation? Of course not. A planet this massive cannot simply spin faster or slower like a toy top. The more likely answer is that something in its upper atmosphere was interfering, masking the true rotation with a kind of shimmering cloak. The mystery of Saturn's day was far from solved, and it only deepened our sense that this was no ordinary planet. Saturn's magnetic field is another puzzle. On Earth, our magnetic field shields us from solar wind and shapes the dancing auroras we see near the poles. Saturn also has auroras, glowing curtains of light at its poles, but here the story is different. You see Earth's auroras brighten and fade depending on the solar wind, but Cassini noticed something curious on Saturn. Its auroras sometimes flared with no connection at all to what the sun was doing. That suggested the energy driving them was not coming from outside but from within the Saturn system itself. Perhaps the culprit was its vast rings or its many moons, feeding electrically charged particles into Saturn's magnetosphere. And then there's the field itself. Saturn's magnetic moment is colossal, more than 500 times stronger than Earth's. Yet its perfect alignment with the axis of rotation defies the very theory we use to explain how planetary magnetic fields work. According to the rules, it shouldn't exist. As it does yet here, it is vibrant and powerful. As we look at Saturn, we're confronted with something unsettling: a world whose magnetic field not only protects it, but also breaks the very laws we thought were unbreakable. To understand Saturn's strange behaviour, we need to dive beneath its golden clouds. On the outside, Saturn looks serene, its pastel bands swirling gracefully. But the deeper we go, the more alien it becomes. Saturn is made mostly of hydrogen and helium. Near the top, these elements exist as gas. But under the crushing pressure of a giant planet, gases don't behave the way we're used to. At thousands of kilometres below the clouds, hydrogen is forced into a liquid state. Descend further, and that liquid hydrogen is squeezed so tightly it transforms into something exotic, metallic hydrogen. This substance is thought to conduct electricity, creating immense currents that may power Saturn's intense magnetic field. And then there's an even stranger idea. As carbon is compressed deeper inside Saturn, it may crystallize into diamonds. Imagine vast storms raining solid diamonds, glittering before vanishing into the abyss of Saturn's depths. What seems like fantasy could in Saturn's furnace be reality. But the story doesn't end with pressure alone. Heat is another part of the puzzle. Saturn radiates nearly twice the energy it receives from the Sun. Some of this comes from gravity itself, as the planet slowly contracts under its own weight-releasing heat, but scientists believe the rain of helium droplets sinking through the hydrogen layers, and perhaps those diamond storms too, generate friction, producing even more warmth. It's a world alive with movement beneath the clouds, oceans of metallic hydrogen, invisible storms of diamond rain, and heat rising outward to shape Saturn's strange atmosphere. If the heart of a planet can be so dynamic, perhaps it is there in Saturn's hidden depths that the answers to its mysteries are waiting. For years, Saturn's day length seemed impossible to pin down. Magnetic fields gave no clues. Radio emissions shifted unpredictably. It felt as though Saturn itself was hiding the answer, but eventually scientists realized that the key might not lie within the planet, but in the rings that encircle it. Saturn's rings, though delicate and thin, respond to the pull of Saturn's gravity. If the planet were perfectly spherical, its gravitational tug would be uniform. But Saturn bulges slightly at its equator, and its rotation causes tiny fluctuations in gravity. Those ripples in turn leave subtle patterns within the rings. By carefully studying Cassini's measurements of these waves like seismologists, listening to earthquakes through the Earth's crust, scientists were able to read Saturn's internal heartbeat. Each ripple was a clue, and together they revealed the rhythm of Saturn's core. The result, at last a precise measurement, one day on Saturn is 10 hours, 33 minutes and 38 seconds. This discovery was more than a number on a chart. It showed that Saturn's rings were not just beautiful ornaments, they were instruments recording the hidden vibrations of the planet itself, and through them Saturn finally revealed one of its most basic truths. While Cassini unlocked many secrets about Saturn itself, some of its most remarkable discoveries came from its moons. Chief among them is Titan, the largest of Saturn's companions. If Saturn is a mystery, then Titan is an echo of Earth, familiar, yet profoundly alien. Titan is the only moon in the solar system, with a thick atmosphere rich in nitrogen like ours, though missing oxygen. Beneath its orange haze lie rivers, lakes, and even seas, but instead of water, they are filled with liquid methane and ethane flowing in cycles much like rainfall on Earth. Clouds gather methane rains down, and rivers carve into the icy crust. Titan has its own weather, its own seasons, and perhaps even the chemistry that could lead toward life. It's no wonder that NASA's next major mission, Dragonfly, is heading there in 2027. This drone-like probe will fly across Titan's landscape, sampling, measuring, and searching for the building blocks of biology. It may not answer Saturn's magnetic riddles directly, but it could tell us what makes Titan one of the most Earth-like worlds we've ever found. As we look to the future, Titan reminds us that Saturn's system is not just one planet. It's a miniature solar system of wonders waiting for us to return. Saturn is not just a planet. It is a system alive with motion, balance, and change. Its atmosphere pulses with winds that can circle the globe at incredible speeds. Its magnetic field thrums invisibly, bending radiation and shaping auroras that glow at the poles. And its iconic rings, perhaps the most beautiful structure in our solar system, are delicately held in place by Saturn's gravity and rhythm. But even these rings tell us a bittersweet story. Evidence suggests They may be surprisingly young, perhaps only 100 million years old, a blink compared to Saturn's age of over 4 billion years. And they are not permanent. Slowly, particle by particle, the rings are falling back into Saturn's atmosphere. In another 100 million years, they may be gone entirely. That means we live in a uniquely privileged moment in cosmic history. If humanity had appeared earlier or later, Saturn might have looked utterly different, just another banded gas giant stripped of its shimmering crown. It's tempting to think of this as a gift. Saturn does not choose to share its beauty with us, but by chance we exist in the era when it does. And in witnessing it, we are reminded how fleeting and precious cosmic wonders can be. As Cassini's mission ended in 2017, the spacecraft plunged into Saturn's atmosphere, burning up in a final act of discovery. It was the only way to ensure that no earthly microbes could ever contaminate Titan or Enceladus worlds that might one day reveal signs of life. In its final moments, Cassini continued to send data, teaching us about Saturn right until the end. What remains is a legacy of knowledge, but also of mystery. We now know Saturn's exact day length, we understand more about its storms and rings, and we've seen the possibility of oceans hidden on its moons. Yet the questions are far from over. Why is its magnetic field so perfectly aligned? How does it generate more heat than it receives? And what forces drive its auroras from within? These mysteries remind us that Saturn is more than a distant ball of gas. It is a laboratory of the cosmos, challenging our theories and humbling our assumptions. Let's carry that sense of wonder forward, because Saturn still has more secrets to share. And so Saturn remains a mystery. Cassini gave us a glimpse into its hidden depths, solving some puzzles while uncovering many more. Its storms, its rings, its magnetic secrets all remind us that the universe is far more complex and wondrous than we often imagine. One day, new missions will return, and perhaps then we'll find the answers. Until that time, Saturn will continue to inspire awe, standing as a reminder of how small we are and how vast the cosmos truly is. Thanks for joining us here on Cosmic Compass. Until next time, keep looking up.